they're saying the equation, this has these roots, okay? Then they're saying find the values of this, and then find the value of that. Then B, they're saying find an equation whose roots are this guy, okay? So how do you find this? How do you solve this question? It's linked to this question, okay? So you start it from the top until the bottom, okay? So we can see that we have been given an equation here, which is 4x squared plus 8x minus 1, okay? Which is equals to 0, which has roots alpha and beta, okay? So we know that identities for alpha and beta is that alpha plus beta, okay? Alpha plus beta is equals to minus b over a, okay? That's the identity for alpha plus beta, okay? Then we have alpha being multiplied by beta is equals to c over a, okay? So these equations, you must have them in your head, okay? Because whenever they give you an equation about alpha and beta, they want you to use the same, okay? They want you to use the same. So we can go and solve it from here, okay? So we can start. They have given us 4x squared plus 8x minus 1 is equals to 0, okay? Then we know that from this equation here, we can get our A, okay? Our A will be equals to what? 4. Then our B will be equals to 8. Then our C will be equals to what? -1, okay? So let us find the sum of alpha and beta. So sum of alpha and beta is equals to minus B, okay, over A, okay? Which will be equals to minus, you can see 8 there, over, what is our A? Our A is 4, okay? Meaning this one will just give us what? -2, right? Okay, so that is our alpha plus beta there. Then let's find our product, okay? So alpha multiplied by beta is equals to, we know that alpha multiplied by beta is equals to C over A, okay? Which is equals to, what is our C? -1. -1 over, what is our A? Our A is 4, okay? So from the information that we've been given here, we've managed to find alpha plus beta. We've managed to find alpha multiplied by beta. So what next now? The thing that we are going to find is we are going to get these expressions because they want us to find the values of this, okay? So we have to find the values of this, but we can't just find the values of this direct. We have to simplify this guy. We also have to simplify this guy. That's when we can find the values, okay? So let's simplify it. So there we have this guy here, like, okay, let's draw. Okay, remember. So we have A to the power 3 beta, okay, plus alpha beta to the power 3, okay? So this is the expression that we have, but we can't just put in these values because in this expression, there's no x, there's no alpha plus beta, and there's no alpha times beta. So we have to simplify this guy here so that we take it into the terms where it has alpha times beta and alpha plus beta, okay? So if we are to simplify this, then we'd say it's equals to, we can see that alpha is common here, alpha is common, beta is common, beta is common, okay? So we can factorize the alpha beta there, okay? Meaning inside, what are we going to have? We're going to have alpha squared plus beta squared. Alpha squared plus beta squared, okay? Then moving forward, we know that this guy here does not exist in this form. So we have to simplify. And this guy here has an identity, okay? It has an identity, okay? So you have to know the identity of this. You have to know by heart. So to be alpha beta here, then open brackets. Then the identity for this guy, we all know that it's alpha beta. It's alpha plus beta squared in the bracket, then -2 alpha beta. Okay, so this guy here, alpha squared plus beta squared, it has its own identity, where you have alpha plus beta, okay, then squared. Then what else do we have? We have -2 alpha beta. So this guy has to be in your head because you have to know this identity. Whenever you see alpha squared plus beta squared, just write this, okay? So you can see now that this expression, contains exactly what we did, what we found here and there. Okay, you can see alpha plus beta, you can see alpha times beta there. Okay, so after finding that, you can now replace it with the values. Okay. Uh, Sorry guys, I received the call. Okay, so we can continue. So I was saying we found alpha beta there, alpha plus beta, then again alpha beta there. So we can put in the values. We know that alpha beta is just -1/4, -1/4. Okay, -1/4. Then this side we have alpha plus beta squared. So we know that alpha plus beta squared is -2. Okay, -2 squared. Then you have -2. Then your alpha beta again there is 1/4. Okay, 1/4. Okay, so simplifying this, what do we get? Here we still have 1/4. Okay, 1/4. Then inside here, what do we have? We have 4 there. Then here you have a minus, even there a minus. When you multiply 2 times 1 there, here inside you just find that it's positive 1/2. Okay, so that's what you have there. Then you add them. So when you add that, it just be 1/-4. Then inside there to be what? What is 4 plus half? It's just 9/8. Quick mathematics, 1/8. Okay. Then, oh, I mean 1/2, not 1/8. Ish. Okay. So 9/2 in the brackets. Then we multiply here. Okay. We multiply here. So what is it? -1 by 9. Definitely it's -9. What is it? 4 by 2. Definitely it's 8. Okay. So this will be your answer. Any questions, guys? Is it clear how we have come up with this guy here? Hello?
It's clear, sir.
Okay, thank you. So let's move to the next one. So the next one was saying we have this guy multiplying this guy here. Okay, so again, the main thing here is to express whatever expression that you've been given in the form alpha plus beta or alpha times beta. So we can see that this is multiplication. So here we can just multiply everything and put the like terms together. So here you have alpha to the power 4. Okay, because there it was 3 and there it's 1. So that's just alpha to the power 4. And again here you have your beta to the power 4. Okay, then equals. So here you can factorize the power. So you have alpha beta there. Okay, then you have the power 4 outside there. Okay, so you have that. Then equals to. Now you can replace this alpha beta with its value. So you go back here, you check what is our alpha beta. Alpha beta is -1/4. Okay, so we come back here and then we put our 1/4. Okay, so 1/4 to the power 4. Okay, so what is -1 to the power 4? -1 times -1 times -1 times -1. You had 4. Just give you 1 still. Okay, then here down, what is 4 to the power 4? 4 times 4, 16. 16 times 4. 16 times 4, is it 256? Yeah, it should be 256. 16 times 4, 128, then okay. Yeah, so here it will be 256. Okay, so this is your answer here. Okay, I hope it's clear. If you have any question, just unmute yourself and ask. Okay, then the next question there it was find an equation whose roots are this guy here and this guy. But we can see a similarity here. We had this equation and they said find the values of this. Okay, so it means even if we find this, we're still going to find this equation. Okay, but let's find it just for the sake of. Okay? Let's find it just for the sake of. They are saying these two are the roots. Okay, these two are the roots. Okay, and we know that. Okay, we know that x alpha plus beta there is equals to -2. Okay, and alpha multiplied by beta there is equals to what? We said 1/4, right? Okay, 1/4. Okay, then we have the roots as we have the roots as beta there, and the alpha beta to the power 3. Okay, so we are trying to, what is the equation here? They're saying find an equation whose roots are this and this. Okay, so we have this root and this root, then we are trying to figure out the equation from where they came from. Okay, so we know that whenever you are given such equation, the new equation will always be in the form x squared minus sum of alpha plus beta x, okay, then plus their product there. Okay, so this is the new equation, and we already have these values. We already have the sum of this, and we already have the product of that. Okay, so you'll just replace. Okay, so the new equation will be equals to x squared minus what is it? Alpha plus beta is just minus 2. Okay, then you have your x, then plus what is my alpha beta? My alpha beta is -1 over 4. Okay, -1 over 4. Yeah, so we have something like this. Then you can simplify it. You say x squared plus this will just become 2x, then there to be a -1 over 4. Okay, so you can see that this equation is the same as this equation that we are given. Okay, this equation is the same as this equation. How? You just multiply it by 4. Since we have 4 as a denominator there, you can multiply everything by 4. Okay, so if you multiply everything by 4, you are going to have your 4 squared plus 8x. Okay, then here when you multiply 4 by 1 over 4, it's just going to give you 1. Okay, so this is the equation that they want. Okay, so this question was simple. They already gave you the answer. They just wanted you to substitute. You can even tell by the marks allocated here. Okay, so the first question that we did was 6 marks, and this one that we are from doing was just 2 marks, because it is just inputting the sum into this formula here. I don't know what this formula is, but it's a correct one. So inputting the sum there and inputting the product there, then you have your new equation. Okay, yeah, hope that is clear. Okay, okay, so here we are remaining complex numbers and this guy here and binomial. Okay, so let us finish this guy here. Let's finish this question here, then we call it a day. Okay, don't want to give you guys a lot of things. Okay, so let's solve this question. So you're saying, given that the root of 2 is irrational, show that root of 2 plus 3 is irrational. Okay, so this is very simple. I expect everyone here to know. Okay? So how do you prove such? You say suppose. Okay, you say suppose. Okay, I'm not going to write it to take time. Okay, I'll just be explaining, so make sure you pay attention. Okay, so suppose the root of 2 plus 3 is irrational. Okay, if this guy here is irrational, you should be, like when you're answering, you should be writing whatever I'm saying. Okay, so suppose root of 2 plus 3 is irrational, then there exist 2 numbers, okay, P and Q. You can also use A and B, B and C, whatever letter you are comfortable with. Okay, suppose root of 2 plus 3 is irrational, then there exist 2 numbers P and Q, okay, where Q is not equals to 0, okay, where Q is not equal to 0, and P is being divided by Q, okay. Okay, so I was saying, suppose this guy is irrational, then there exist 2 numbers P and Q, where Q is not equals to 0, and this guy here has no common factors, okay, has no common factors, no common factors, okay, has no common factors. Then you start your proof now. So you first write the statement there. Suppose this is irrational, then there exists P and Q such that Q is not equals to 0, and P over Q has no common factors. Okay, so you say now that your root of 2 plus 3, okay, is equals to P over Q. Okay, then the root remains alone there. The 3 goes to the other side. Okay, minus 3. Okay, then from there, what do? We subtract that expression. So the square root of 2 is equals to, when we combine this guy, you have your Q there. So P into Q, just 1, and you have your P there, then minus this 3 to be over 1. 1 into q is q. Then there you have your 3q. So now here you have this guy being equals to that guy. Okay. And then from this, that's where you prove your contradiction. Okay. So you say the left hand side, okay, the left hand side is equals to the square root of 2. And you know that the square root of 2 is what? Irrational. Okay. But the right hand side, okay, right hand side is equals to p minus 3q over q. Okay. So right hand side is equals to p minus 3q over q. And we know that p and q are integers. Okay. So if this p and q are integers, then definitely this guy will have it will have a common factor. Okay, it will have a common factor. Okay, and since it will have a common factor here, it means that this guy is what? Rational. Okay, is it rational? So you have the left hand side being irrational, and then the right hand side being what? Rational. Okay, and if the right hand side and the left hand side they are not equal, then that proves the one. Okay, so you say since the left hand side, okay, is not equal to the right hand side. Okay, since the left hand side is not equal to the right hand side, okay, hence by contradiction, the root of 2 plus 3 is irrational. Okay, the root of 2 plus 3 is irrational. Okay, so that's how you go about that question. Okay, do you have any questions, guys, or we can move?
Can move to the next question.
Okay, so the next question, which is our last question for today, because I don't want to overwhelm you people, we are just expressing this guy here as a fraction in the form p q, where p and q are what? They're integers. Okay, that's what I'm doing. We'll go to my board here. So we are saying express 0.0810 a bar on top there, meaning these three letters are always repeating. Okay, so immediately after 0 here again starts 810, just like that until infinity. Okay, so we're expressing this guy into the form p over q. Okay, p over q. Okay, so what's the first step? The first step is to let this guy here be equals to x. So you say x is equals to 0.0810. Okay, you put your bar there. Then after that, you say 10x. Why are we writing 10x here? Because we want this decimal point to move a step forward, so that after the decimal point, we only have the values that are repeating. Okay, we only have the values that are repeating. So 10x, meaning this point has moved one place in front, will be equals to 0, 0, then point, it has moved there now, 8, 1, 0, then you have your bar there. Okay, the bar should reach where 0 is, you have a bar there like that. Okay, then after writing that now, the next step is to move the point from this guy here to this guy, where the next 810 starts. Okay, because we said this number is recurring. It keeps on going 810, 810, 810 until okay. So our next target now is to move this point how many times? 1, 2, 3. Meaning here to the 10x, we're going to add 3 zeros. So this one will become 10,000 what? X. 10,000 x. Okay, we have a 10,000 x is equals to, okay, so if we move this point 3 times here, it means our number now will begin at 810. Then you have another set of 810 that are repeating this side. Okay, bar on top like that. Okay, sweet. Then what's the next point? The next item there is to subtract. Okay, so we want to eliminate this part here that is recurring here, the part after the decimal. So we have a part after the decimals here, which is similar to there. Okay, so we want to eliminate this part. So what do? We subtract these two. We subtract 10,000 minus 10. Okay, so it will be your 10,000 here, 10,000x. Okay, 10,000x minus your 10x there. Okay, which will be equals to, what is our 1,000x? I mean 10,000x is just 8, 10, okay, 0.8, 10. Okay, then we come and write our x just below this, follow making sure that the decimal point is in a straight line. Okay, so this is our 10x here. So it means we are going to start from 0, 0, making sure that the point is in the straight line with that. Then you have your 80, 1, 0. Then after this, you do your subtraction now. Okay, so you do both here and there. Okay, so what are we going to get after that? When you subtract, when you subtract 10,000 minus 10, we are going to get what? 9,990x. Okay, which will be equals to, let's subtract these guys. So here, when you subtract 0 minus 0, 0, 1 minus 1, 0, 8 minus 8, 0. So after the decimal point, we have nothing. So only have 810, like that. Okay. Then here now, we can find our x, which will be the expression that we are looking for in the form P over Q. Okay. Okay. So we can find our x now. So x is equals to 810 over 9990. Okay. So here now we can simplify this. So we can look for a number that can go into both of these numbers. So into what number can go there? The one that is common. Okay, I can see 10 there. So if 10 goes there, 10 goes there, the zeros will go. So it will just be 81 over 99. Okay. Then can we still find a number that can go into 81 and 999? Okay, 3 can go into there. So 3 into 81 is just 27 over. Then 3 into 999. 3 into there, 3. Okay. So it will be 3, 3, and 3. Okay. I can also see 3 is going into this guy and this guy. So 3 into 27, it will be 9. It will be 9. Okay. Then 3 into 3, 3, 3, it will be 1, 1, and 1. Okay. So do we have a number again where 3, where a 3 that can go into 9 and 1, 11? Do we have a number? Guys, do we have a number that can go into 9 and 1, 11? Hello? Okay, yeah. 3 can go into this guy and it also can go into this guy. So 3 into 9?
3
just,
can go in.
Yeah, 3, yes. So 3 into 9 is just 3 over. Then 3 into 1, 11. You have 3 into 11, it will be 3. Then remainder 2. Okay, so this will make 21. Then 3 into 21 is just what? 7. Okay, so your final expression will be that guy there. Okay, to be this guy. Okay, so when you're done, you can write that 0.0810 bar on top there is equals to the same as 3 over 37. I hope we have found the correct thing here. Okay, so you can check this on your calculator. 3 divided by 3, 37 there. Make sure it gives you this. Okay, but I'm sure I've gotten the concepts. Okay, yeah. Okay, so I think that's it for today. We'll continue tomorrow. Okay? Continue tomorrow. Same time, we'll be having these classes at 20 to 21 something. Okay. So those ones to register, you can inbox this number so that we prepare together for these subs. Okay. You can join the group on WhatsApp. This is the link. You can just copy it. And these are the services that we offer. Okay. So whatever live sessions we're going to be having, we'll be recording them and we'll be uploading them on the drive. So in case you miss a class, you still have access to it on the drive. Okay, even live tutorials like the one we're doing here, solutions to tests, and they're all there on the drive and well summarized notes. Yeah. Okay. Okay, I can see a message there from Babe. Who's Babe? Yeah. Okay. So that's it, guys. If I have no questions from you, then we can call it a night. Okay, we shall meet tomorrow again, 20 hours. Okay. So can I cut the class? No question? Okay, silence means no question. Okay, thank you guys and have a blessed night.